All right, let's dive into one of the biggest, weirdest questions in all of physics. What in the world is light? For centuries, this puzzle drove the smartest people on the planet crazy. And the answer, when we finally got it, completely changed how we see reality itself.
So, let's break it down to a simple choice. Is light a wave, spreading out continuously like ripples in a pond? Or is it more like a stream of tiny individual things, like a hail of microscopic bullets? For a long, long time, the world of science was pretty sure it knew the answer.
And they were all in on Team Wave. Our story really gets going back in the 19th century, a time when it really seemed like scientists had this whole light thing totally figured out. And for most of the scientific community, the evidence was just overwhelming. Light was an electromagnetic wave moving through space, just like a wave moves through water. It was a beautiful, elegant idea that just worked. It explained almost everything they could see and measure.
And the proof just kept piling up. Back in the early 1800s, experiments proved that if you shine light through narrow slits, it creates these interference patterns, bright and dark stripes, exactly like water waves do when they overlap. Then, by the 1860s, it was confirmed that light was just one piece of this huge electromagnetic spectrum. So, case closed, right?
Well, not so fast. You know how it is in science? Just when you think you've got it all buttoned up, a little crack appears in the theory. And this one started with something incredibly simple: the glow from a hot object. It was a mystery that wave theory just couldn't solve.
The problem had a fancy name: black body radiation. Now that sounds complicated, but the idea is pretty straightforward. A theoretical black body is just something that perfectly absorbs any light that hits it. And when you heat that object up, it starts to glow. Just think of a blacksmith heating a piece of iron, or even the burner on an electric stove.
So here's the kicker. When physicists tried to use their perfect established wave theory to predict what colors of light a hot object should be giving off, the math completely fell apart. I mean, it wasn't even close. The predictions didn't match what they were seeing at all, and nobody had a clue why. And you've seen this happen yourself for sure. As you heat up a piece of metal, it first starts to glow a dull red. Crank up the heat, and it becomes a bright orange. And if you could get it super hot, around 6,000 Kelvin, like the surface of our sun, it glows white hot. But the wave theory just couldn't explain this very predictable change in color.
The solution to this puzzle didn't come from just tweaking the old theory. Nope, it came from a completely new, totally revolutionary idea, one that was about to kickstart a whole new kind of physics. So, in the year 1900, a physicist named Max Planck came forward with this wild idea. He basically asked, what if we're thinking about energy all wrong? What if it's not a smooth, continuous river? What if it actually comes in tiny, individual packets? He called these little energy packets quanta.
And that right there is the key difference. The old wave theory pictured energy like water flowing from a faucet. You can have any amount you want, a trickle or a flood. Planck's quantum theory was more like a gumball machine. You can't get half a gumball. You can only get them in whole individual units. It sounded bizarre, but it worked. It solved the blackbody problem perfectly.
A few years later, a young guy you might have heard of, named Albert Einstein, took Planck's idea and ran with it. He reasoned that if energy comes in these packets, then light itself must be these packets. And he gave them the name we still use today: photons. He was talking about particles of light.
So now physics had a huge problem. Was light a wave, like a century of experiments had shown? Or was it a particle, like Planck and Einstein's new theories demanded? Well, the answer turned out to be yes.
So who was right? Team Wave, with all their experiments showing interference patterns, or Team Particle, who just solved this impossible black body puzzle? It seemed like a flat-out contradiction. How could both be right?
But in the incredibly strange world of quantum mechanics, contradictions can be true. It turns out both camps were right. Light is somehow simultaneously a wave and a particle.
This mind-bending idea is called wave-particle duality. It says that light doesn't have to choose. It is both, and it just shows us one side of its personality or the other depending on how we decide to measure it. And the really crazy part? Physicists soon found out this wasn't just some weird quirk of light. It's a basic rule for all matter at the quantum level.
So what does a photon actually look like? Well, the best way to picture it is as a wave packet. Imagine a single, tiny bundle of energy, that's the particle part, that travels along a path determined by a wave. It's kind of like a particle surfing its own wave across the universe.
So what does this all mean in practice? Here's the takeaway. When light is just flying through empty space, it acts like a wave, spreading out. But the instant it hits something, like when a photon hits a cell in your eye, it delivers all its energy in one particle-like punch. This discovery didn't just add a new chapter to the physics textbook, it tore up the old book and forced us to write a completely new one about reality.
And that's the truly profound thing here. Wave-particle duality proved that the universe, at its very core, is so much stranger than our everyday common sense can even begin to handle. It really makes you wonder, doesn't it? If something as basic as light can be two completely different things at the very same time, what other incredible secrets is reality hiding from us, just waiting for the right question to be asked?